Запись идет.
Ага, давай начни.
I would like to tell you about pharmacodynamics, especially about ion receptors. Pharmacodynamics is the study of how drugs have effects on the body. The most common mechanism is by the interaction of drug with tissue receptors located as in cell membrane or in the intracellular fluid. I think that it is important to know the difference between pharmacokinetics and pharmacodynamics. About pharmacokinetics, we studied pharmacokinetics in previous lesson, and for today, we going to tell you about pharmacodynamics. Like the main difference is that pharmacokinetics is the study of what the body does to the drug, and pharmacodynamics is the study of what the drug does to the body. Another easy way to remember what pharmacokinetics means is to reference the definition of kinetics. Kinetics essentially means movements, but by definition is the study of forces acting on mechanism. So pharmacokinetics refers to the movement of any drug going into, through, or out of the body. And about pharmacodynamics, it means like energy. Dynamics means energy and power, but in terms of pharmacodynamics, it refers to how the drug works and how it exerts its power on the body. When it comes to pharmaceuticals, pharmacodynamics focus on receptor binding, post-receptor effects, and chemical interaction. And what is the receptors? Receptors are functional macromolecules that are selectively sensitive to certain chemical connection. The medical substance can be divided into it is agonist and antagonist. Agonist it is activate receptors due to their similarity to a natural mediator, and antagonist is prevent the action of specific agonist. Partial antagonist, partially stimulated receptors. The ion channel linked receptors. There are two general classes of ion channels. It is voltage gated and ligand gated. The voltage gated ion channels are actively by alteration in membrane voltage. Voltage gated sodium channels open when the membrane is depolarized to threshold partial and contribute to further membrane depolarization by allowing the sodium influx into the cell. The local anesthetics such as lidocaine bind to the voltage-gated sodium channels, leading to blockade of neuronal depolarization. And specific voltage-gated ion channels also exist for potassium channel, calcium, hydrogen, and chlorine. In contrast, like ligand-gated ion channels are activated in response to the binding of a specific ligand or drug. Many neurotransmitters and drugs and some cytoplasmic ligands activate the membrane-bound ligand-gated ion channels, including like the several type of receptors. And 1,5-hydroxy tryptamine receptors promoting the sodium, potassium, or calcium movement. And here in this picture you can see the representation of the amino acid sequence relation of the minimal pore region of the voltage gated ion channel superfamily. This global view of the 143 members of the structurally related ion channel genes. And as you can see, it's divided into 7 groups of uh, ion channel families, like 4 domain channels. As you can see, calcium and sodium are shown as the blue branches. Also, we have the potassium selective channels are shown as the red branches, as you can see, and also we have the cyclic nucleotide gated channels. They are shown as the orange, and also the transient receptor potential are shown as the green branches. And background color separate the ion channel protein into related groups, like light blue it is calcium and sodium, light green is the transient receptor potential, also light red is potassium channel, and the uh, the такива. And yes, light green is a transient receptor potential, and
Orange, you forget, I
as
think.
a
Nucleotide dependent, yes?
yes, yes, oranges it is, you can see the what potassium V 10 to 12 it is orange. Also, the defects in ion channel function cause the wide range of disorders termed channelopathies, which include the condition resulting from the mutation in ion channels. And like disease caused by autoimmune attacks on ion channels. That's all.
Can you repeat in the previous picture you said about the, can you return? What was about the blue one?
The blue one, it is calcium and sodium. They are represent like in blue branches, as a blue
Are they,
branches.
are they voltage dependent channels, calcium and sodium?
Calcium, calcium and sodium. It
Yes,
is a
yes.
blue branches.
And they are voltage dependent, yes?
Yes.
So can you say like that the voltage dependent channels divided to the two? So calcium is could be open in the lower membrane voltage, like a minus 60, yes? And the sodium only can be open in the minus 45 volts. Can we say like that? Or we cannot?
Um. Sorry, I don't understand you.
So here you are making like a saying like a calcium channels, and we divided
Yes.
calcium channels to the two. In the previous slide, you shown that voltage dependent and what was dependent also previous? Can you
Voltage dependent ligand gated.
ligand gated? Yes. So
Yes.
we have L-type calcium channel and the T-type calcium channels. Yes. L-type calcium channels, mostly it is the voltage dependent channels. Yep.
Yes.
And the transient is also voltage dependent.
Yes.
Okay. Orange one, it is the ATP energy dependent. Yep. Or cyclic
The
nucleotide.
orange one, it means
Potassium.
this one, yes,
Yes.
yes.
What is the CNG and the HCN? Can you say me what is the substitution site 0.05? What does that mean in your picture with the small letters in the brown?
It is
Yes, yes, yes.
That's it is the substitutions. So,
Substitutions. Oh, now I can see this IR potassium channels. Yes, this is the nucleotide dependent IR cyclic IMP dependent calcium channels. This is the small conductance and the big condensate calcium dependent potassium channels. Yes, left side from the key.
this one,
Yes,
the
no, no.
key are
Key IR, it is the like a joke channels. Yes, potassium joke channels. It can go to the activation, it can go to the slowdown. It is this about the symmetrical calcium channels or potassium channels. This is the calcium dependent potassium channels. They have a 3 types small conductors. Can you go forward to the left? So this is the calcium dependent potassium channels. Okay, so they could be closed when the calcium levels, or they can be opened when the calcium levels get higher. Yep. What is this one? KV1 and 9. What is their function? Okay, move forward. A little bit upper. CRP channels. I cannot see the letters of the next one. Can you make it bigger? K2P. Okay. KV1012. CNG, HCN. Calcium voltage dependent and the sodium voltage dependent. Okay, that's it. Thank you. Thank you so much. And the next page, what you have in the next page?
the reference list.
Okay, pharmacodynamics, pharmacology education project. Pharmacodynamics is mechanism, drug structure, pharmacodynamics, 2000 изображений, Яндекс картинки, Яндекс KZ. Okay, thank you so much. Let's go to the guys. Do you have a questions about the sodium channels? Sodium channels is also playing one of the biggest role. They're working fast in the central nervous system. Their role is essential. Yes, all of these diseases related to the epilepsy is related to these channels and energy changing, working of the heart, creation of the impulses. Also regulation of the work of the blood vessels, small conductors, hypothalamus. Yep. Okay.
Yeah.
Thank you so much. Next, please.
I'm next.